Alright guys, so what we're doing today is we're going to be explaining how to show two triangles are congruent and different postulates and stuff like that we can explain. So first let me show you the symbols of what it means for two triangles to be congruent. Alright, so if I draw two triangles, there's different things that make these, like, show that these triangles are congruent, or different parts of the triangles are congruent. First part, guys, is just a tick mark. A tick mark shows that a side is congruent. Alright, so these two sides are congruent because they both have one tick mark. If we use two tick marks, that shows that these two sides are congruent, but they aren't congruent to the original. So that's saying, okay, so this is congruent to this, but this is not congruent to this because this has one tick mark, this has two tick marks. Three tick marks, the same thing. Okay, we're showing that these two sides are congruent. Alright, that this side and this side is congruent, but it's not congruent to any of the other sides inside this triangle, or any of the sides of the two or the one in the other triangle. So that shows you that the different parts of this triangle are congruent. Okay. The second part is what's known as angles. Okay, so angles, this little curvature thing here. Alright, so this little curvature here means an angle. Now if we have one in here and we have one here, that means that these two angles are congruent. Alright, if I do it again, notice how I keep adding more curves. There's two curves, that means that this angle is congruent to this angle, but this angle is not congruent to this angle because this has one curve, this has two curves. Same thing, 1, 2, 3, if I do it for 3 times, that means that this angle is congruent to this angle, but they're not congruent to each other. Now, when you have things like this, so I'm going to label this A, B, C, and this is D, E, F. If we had two triangles like this where all the parts are congruent like this, we can say something like this. Okay, A, B, C. So we put a little triangle in front, A, B, C. It's congruent to. What this means right here is the congruent mark. It's an equal sign with a little squiggle above it, meaning that this is congruency. They are not the same, but they're equivalent. So, triangle ABC. Okay, now notice how I'm going to do this. D, E, F. Notice how I have the angles A and D, B and E, C and F. They're in the same order here. It's because when we do triangles, we have to do that. So, in here, I'm going to draw one and see if you guys can figure this one out. Things match up with what they're supposed to match up with. Okay, so those two triangles, I want you guys to see if you can figure out how this is congruent. Or how, actually not how it's congruent, but show me what I did up here, but down here. Okay, so the answer would be, okay, so we'd say, first we'd say triangle XYZ. Now, X is in the first position, so here's X. Let's see, what else is in the position that has three marks here? Well, N and X are both congruent, so then we're going to use, N's going to be our start. Then we got Y in the middle, so Y is the one with the 1, so that means that we're using O. And then finally Z is the last, and since M is like Z, we put Z, or M right here. Okay? I didn't put it M and O and XYZ, it's XYZ is congruent to NOM. NOM is congruent to XYZ. That just shows you that you have to look at the congruency marks. You can't just go in alphabetical order. You have to look at the congruency marks and see which matches with what, because the letters have to be in the same position as the ones they're congruent to. Now, little hints. Okay. Now, if we have two triangles like this, okay, if we have two triangles like this, there's something we gotta know, and that's what's known as vertical angles. Okay, so you have these two angles, these two parts right here that are connected. Right? Technically, this is just two lines intersecting. And when two lines intersect, they create vertical angles, and these angles are congruent to each other. So just know that if you have something like this, you know right away that this is congruent to this. Okay? Because they're vertical angles, they're congruent, you know that's congruent to that. Or in this case, we have two things touching. Now this is a little bit confusing because I'm going to try to explain this, but this is going to be a little confusing because when we say sides are congruent, notice how they share a side. These two triangles share a side, so technically it's congruent to itself. Alright? So if I were to say this is line, let's call this A, B, C, D. Alright, we would say that BC is congruent to BC. Okay. This is used so that way we can, when we're trying to prove two triangles are congruent, that we can do so. So this is whenever they share a side, that means that it's congruent to itself, and so on and so forth. Alright. Now, to get into a little bit more tricky things, we have four we have four triangle theorems, okay, that we're going to sit here and explain. Okay, so the first triangle theorem. It's called angle, side, angle. Okay, it's called angle, side, angle because of the fact that if we see an angle that's congruent, a side that's congruent, an angle on the other side that's congruent, then we know both triangles are congruent. So as you can see here, actually let me put little two tick marks here. It goes angle, side, angle. Now for it to be angle, side, angle, the side has to be in between two angles. I mean, the side that the two angles share should be the side that is marked for it to be angle, side, angle. Okay, so angle, side, angle is one of them. Then you have angle, angle, side. Now this is a little bit different. Okay, up here the angle was shared by the common side the two angles had, because this is technically one angle, this is another angle, and the side they share is this one, so that's one that was congruent, so that's angle, side, angle. Angle, angle, side, okay, is where you have two angles, but the side that's congruent is not shared by both angles. So this would work, or both of these will work, because as you can see, the side that is not being shared, one of the sides that is not being shared is the one that's congruent, and you have two angles that are congruent. This is known as angle, angle, side. Then you have side, side, side. That means if all three sides are congruent, then the triangles are congruent. Okay. So we have 1, 2, 3, and finally have side, angle, side. Okay. This is where you have two sides that are congruent. Okay, so this side's congruent to this side's congruent to this side, and the angle in between, because this angle has to be in between here, is also congruent. So, now the two things that we cannot spell, okay, we cannot use angle, 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 and we can't use side, side angle. Okay. This one in reverse spells a bad word, so think about that. You can't spell a bad word, and AAA is an insurance company, not a theorem. So we can't use either of these things. So that means if you see angle, 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 or you see angle, side, side, that means there is no solution, there is no answer, nothing. Okay? So, I'm going to give you some practice ones right here, and then I want to see if you guys can figure them out. See if you can tell me which postulate this is. Okay, so we have 1, 2 angles. Okay, now that narrows it down to one of two postulates, and we have a side. But since they do not share this side, the two angles do not share the side, meaning it's not in between them, we are doing angle, angle, side. So the answer to this is angle, angle, side. Okay, let's try another one. What is this one? It should be side, angle, side. Because you have a side, an angle, and a side. Alright, now let me get it a little more tricky. How about this one? It's a little tricky because remember in the previous one when I explained that when they share a common side, that side is congruent to itself. So this is what we do. We show this. Say this side is congruent to itself. Okay? And since this side is congruent to itself, alright, technically we have a side-side angle. I'm not side-side angle, side-side-side. Because if I separated these two triangles, it would look like this. You'd have one triangle, and then you'd have the other triangle. Now this side used to be connected, alright, they used to be together like over here, but since I separated them, you can see that since they shared this common side, that obviously it's going to be congruent to itself, but when separate, these are two separate triangles with three congruent sides. Alright, let me show you another one that's going to be a little tricky. Okay, so actually let me do another one. Sorry. Okay, once again, you see that we don't have enough information right now. Okay? So what we have to do is we have to put in the vertical angle. Remember, the vertical angle are the ones that they share. Okay, so it's something like that. Now you notice because their vertical angles are congruent, I can mark that they're congruent. Now we can say that this is angle, side angle. Now one more. Okay. Now, and so I want you to think about, okay, so if I have this, 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 and this. Okay, so think about this one. Okay. So once again, because these are vertical angles, we can mark them as vertical angles and show them that they're congruent. So now we have angle, angle, angle. We have three angles. Now, as I said before, we cannot have angle, angle, angle is not a triangle theorem. So what we say is we say this. We say not enough information. Because there's not enough information to prove that these two triangles are congruent. They may very well be congruent, but we don't know enough information. Or if you want to shorten it, I always say just put NEI. Now, when it comes to triangles, okay, let's say that I said ABC is congruent to GLM. Okay. Now, if I said something like this is how you'd have to draw it out. Okay. You'd show me two triangles. You label the one ABC, GLM, and then you'd have to show me that everything is congruent. So you'd have to show me that the A to the G is congruent. So you give me one mark. One mark. The B is congruent to the L, so 2 marks. 2 marks. M is congruent to C, 3 marks. 3 marks. Then AB is congruent to GL. BC is congruent to LM. And then AC is congruent to GM. And this is how you'd show that each part is congruent to. Because if I ask you what is angle A congruent to? Well, what's in the same position as angle A? Angle G. So you'd say angle G. So on and so forth. Then if I said AB, or let's go with BC. Side BC. What is side BC congruent to? Well, BC, LM. They're in the same position, and that's how that works. Alright, now get started on your work.